Okay, for the first example here, we're dealing with a spherical balloon and we're pumping air into it. We're filling it up. So that is a volume of a sphere question. All right, so here is our picture. Here are our givens. The volume increases at a rate of 100 centimeters per second. That's the rate of change of volume, dV dt. And it's asking us how fast is the radius. That's a key word, how fast. That tells you that you're looking for a rate, the rate of change of radius. So our unknown is dr dt. How fast is the radius of the balloon increasing when the diameter is 50? So our diameter is 50, that allows us to find the radius is 25. So there is our given, our find, and our unknown. For the third step, our equation, we use the volume of a sphere, 4/3 pi r cubed. We take the derivative. The derivative of v using the chain rule is dv dt, same as v prime. 4/3 pi comes along for the ride. And the derivative of r cubed using the chain rule is 3r squared dr dt. There is the derivative. So again, the third step is the equation. The fourth step is the derivative. Now we plug in. We know that dv dt is 100. 4/3 pi comes along for the ride. We know our radius is 25. And our only variable left is our unknown dr dt. So now you just go ahead and solve it. I would definitely cross off the 3's. So then that gives us 100 is equal to 4 times pi times 25 squared times dr dt. Let's bring the 100 down. Let's go to our calculator and compute 4 times pi times 25 squared. That's going to be a huge number. I am getting 7,853.98 times dr dt. And now we simply divide both sides by that so that dr dt is by itself. 7,853.98 on this side, 7,853.98 on this side. So these are going to cancel. I'm left with dr dt all by itself. And when I divide 100 by 7,853.98, I am getting 0.0127. And that is a rate of change of radius, so that is simply centimeters per second. There's example 1, calculus. Okay, number 2. Here is our drawing. We have a person walking north, and we have a person walking east from the same point. Okay, the person going north is going at a rate of 4 miles per hour. That is a rate, so that's going to be our dy dt. The other person that's going east is going at a rate of 5 miles per hour. So that is our dx dt. All right, we're also given 8 hours. So if someone goes 8 hours at 4 miles an hour, they've gone 32 miles. If someone goes 8 hours at 5 miles an hour, they have covered 40 miles. So those are our distances using the time. To find, so this right here, I wrote out, here's our givens. We were given these 3 things. We found x and y, taking 8 hours times 4 miles per hour and 8 hours times 5 miles per hour. And we can also find z using Pythagorean's theorem. 32 squared plus 40 squared is equal to z squared. And I got 51.22. And the question that is asking us is how fast, so that is a rate, how fast is the distance between them changing. So that is our dz dt. That's what we're looking for. All right, so take a minute, read through this paragraph, and make sure that you understand the picture and how we got all of our information. The third step is our equation. The equation for a right triangle side lengths is going to be Pythagorean's theorem. X squared plus y squared is equal to z squared. The fourth step, we always take the derivative. Make sure you use the chain rule on each variable. The derivative of x squared is 2x dx dt. The derivative of 2y, or y squared, is 2y dy dt. And the derivative of z squared is 2z dz dt. Now we simply can plug in. That's our fifth step. So we plug in. I like to cancel out the 2's. It makes it a little bit simpler. So our x is 40. My dx dt is 5. My y is 32. My dy dt is 4. My z is 51.22. And my dz dt is the only variable that I have left. And now I just solve this. 40 times 5 gives me 200. 32 times 4 gives me 128. I bring down 51.22 times dz dt. If I add those together, I get 328. And it is equal to 51.22 dz dt. And now I simply divide. I divide both sides to get dz dt by itself. So I divide both sides by 51.22. Okay, those cancel out. I've got dz dt by itself. And when I take 328 and I divide it by 51.22, I'm getting 6.4. It is a rate, so I need miles per hour. There's number 2, calculus. Okay, number 3. We have car A traveling west, so that's to the left, at 50 miles per hour. Miles per hour, that is a rate. So that is going to be my dx dt, 50. Car B starts right here and is heading towards the same intersection, and he's going north, so that is up. And he is traveling at 60 miles per hour. That is also a rate, so that is our dy dt is 60. All right, they're both headed towards this intersection. All right, at what rate are the cars approaching each other? So that's our dz dt. This is what we're looking for. All right, and it gives us their distances from the intersection. So car A is 0.3. So that's our x, 0.3, and car B is 0.4 miles from the intersection. Alrighty, so they're both going towards the same intersection. Alrighty, so here's our givens. We were given 4 things, both rates and both distances. We can find z, the hypotenuse of the right triangle, using Pythagorean's theorem. 0.3 squared plus 0.4 squared is equal to z squared, and you get 0.5. And this is what the question is asking us for. The rate of change of the distance between them. Now, this is a negative rate here, because as car A travels towards the intersection, his distance from the intersection decreases. This length is decreasing, so the rate is negative. And same with car B. As car B drives towards the intersection, his distance from the intersection decreases. So the rates are negative. If your function is decreasing, your rates are negative. So always check your rates to make sure that they have the right sign. Alrighty? So again, you can kind of tell if I would have put in that distance, it is smaller than this distance. So their distance is decreasing. So we're going to get a negative answer. All right, so let's go to the third step. We need our equation. X squared plus y squared is equal to z squared. The fourth step, we take the derivative. We use the chain rule. The derivative of x squared is 2x dx dt. The derivative of y squared is 2y dy dt. And the derivative of z squared is 2z dz dt. Write out the derivative. All right, I like to cancel out the 2's. Now let's plug in what we know. We know that x is 0.3. We know that dx dt is negative 50. We keep going. We know that y is 0.4. We know that dy dt is negative 60. We keep going. We know that z is 0.5 and dz dt is our question. That's our variable. All right, so now we just go ahead and we solve it. 0.3 times negative 50 is going to give us negative 15. 0.4 times negative 60 is going to give us negative 24. We bring down 0.5 dz dt. We add and get negative 39. And now to get dz dt by itself, we're just going to divide both sides by 0.5. All right, so those cancel out. My dz dt is equal to negative 78, and that is miles per hour. Alrighty? And just like we said, it is a negative rate because this distance is getting smaller and smaller and smaller as the cars drive towards that intersection. Okay, example number 3, another right triangle problem. We have two cars moving from the same point right here. One is going south at 60 miles per hour, so that is a rate. So that is going to be our dy dt. The other travels west to the left at 25, and that again is miles per hour, so that is our rate. So 25 is going to be my dx dt. All right, at what rate is the distance between the cars increasing? So the dz dt is my unknown. We don't know that. And we have 2 hours. All right, so 2 hours allows us to find this distance right here. If I'm going 25 miles an hour and I go for 2 hours, I have traveled 50 miles. My x is 50. All right, for the car traveling south, if I'm traveling at 60 miles an hour and I go for 2 hours, I have traveled 120 miles. All right, so these were my 3 givens right here, the 2 rates, 25 and 60. They are both positive because these distances are increasing. The side length gets bigger as they drive away from the intersection, so those are positive. We found our x and y using our time of 2 hours. We can also find z using Pythagorean's theorem. 50 squared plus 120 squared is equal to z squared, and I get 130. And this is our unknown. All right, so take a minute, read through that paragraph, and make sure you understand where everything goes and the correct variables and so on. Okay, so third step, we need the equation, good old Pythagorean's theorem. Easy point, x squared plus y squared is equal to z squared. Fourth step is our derivative. We use the chain rule. On every variable, the derivative of x squared is 2x dx dt. The derivative of y squared is 2y dy dt. And the derivative of z squared is 2z dz dt. All right. Simplify it if you like. I like to cancel out the 2's and plug in what we have. So that's the fifth step. We know that x is 50. We know that dx dt is 25. We keep going. We know that y is 120. We know that dy dt is 60. We know that z is 130. And dz dt is what we need to find. All right, so then we compute this. 50 times 25 gives us 1,250. 120 times 60 gives us 7,200. We bring along 130 dz dt. When I add those, I get 8,450. And I bring down 130 dz dt, And now I simply divide both sides by 130 to get dz dt by itself. So dz dt, 8450 divided by 130, I am getting 65 miles per hour. All right, we're going to do a baseball problem. Remember, a baseball diamond is a square. The side lengths are all 90 feet. So the batter starts, he's at home plate, and he hits the ball and he runs towards first base. So he is somewhere between home and first base. I'm going to put him right here. There is our batter. All right, so there is one side of our right triangle. A baseball problem will always be a right triangle problem. You just have to figure out where in that baseball diamond the right triangle is that we're dealing with. All right, so our player is right here. He's running towards first. We're given a speed of 24 feet per second, so that is a rate. All right, I'm just going to give this x and dx dt. Everything needs two rates, so that is going to be 24. It's asking us at what rate is his distance from second base. So his distance from second base, he's right here. His distance from second base is this length right here. So there is the right triangle that we're dealing with in this problem. It's this right triangle right here. There's our triangle. Okay, so we have x and dx dt. Then the other leg of the right triangle is up here. I'm just going to call that y. And then we need a dy dt. And then the hypotenuse of our right triangle is the distance from the batter to second base. And that's going to be our z and our dz dt. So what other information do we have? We know that this rate is decreasing. At what rate is his distance decreasing? When he is halfway to first. Well, if the whole side length is 90 and he's halfway to first, that means x has to be 45. All right, so that's something that we just found. We found x is 45. All right, we know that y, this length here, is the side of the baseball diamond, so that is 90. All right, so that's given to us. Y is 90. We were given dx dt. We were given the rate. Right here is 24. Now, whenever you have a rate, you've got to make sure that you have the right sign. Is it positive or negative? As he runs towards first base, this distance is going to get smaller and smaller. He's running towards first base. So this rate has to be negative. All right? This distance is decreasing, so the rate is negative. I'm going to put it right here too, just so I don't forget. All right, what else? We can find z using Pythagorean's theorem. All right, we can take 45 squared plus 90 squared and find z squared. So just use Pythagorean's theorem. 45 squared plus 90 squared will give you z squared. When I did that, I got 100.62. And the question is asking us, what is dz dt? What is this rate? Right there. So that is our unknown. Okay, now let's just check to make sure that we have everything accounted for our three sides of our triangle. Right here, we have the length, 45. We have the rate, negative 24. For this side, the hypotenuse, we found the distance z using Pythagorean's theorem, and the rate is what we're looking for. So we have everything accounted for here. But this side here, we only have y is 90. We don't have this rate. We need the rate. In this problem, the distance between first and second base never changes. In baseball, you can't just pick up the base and move it. So this distance is constant throughout this problem. There is no rate of change. So dy dt is 0. And that's the last thing that we need to find to do this problem. If something isn't changing, it still has a rate variable, but we know that the rate is 0. All right, so now we can move ahead and solve the problem. We need our third step. We need the equation. X squared plus y squared is equal to z squared. We need our derivative, our fourth step, and we make sure that we use the chain rule. So the derivative of x squared using the chain rule is 2x dx dt. The derivative of y squared using the chain rule is 2y dy dt. And the derivative of z squared is, 2z dz dt. All right, let's cross out the 2's and let's plug in everything that fifth step, plugging it in. X we know is 45. We know that dx dt is negative 24. We know that y is equal to 90. We know dy dt is 0. That's going to make life easier. We know that z is 100.62 and dz dt is our variable. This whole thing is going to go away right here. We know that 45 times negative 24 is going to give us negative 1080. We bring down 100.62 times dz dt, and then we simply divide both sides by 100.62. So dz dt is by itself, negative 1080 divided by 100.62 is negative 10.73. That is a rate, so it needs a fraction for units. It is feet per second, and it is a negative derivative, so we know that this distance here is decreasing. As he runs towards first base, his distance from second base is decreasing. All right, there's the baseball problem. Thanks, calculus.